So today we want to talk about a few derivation of Taylor polynomials for some famous functions: e to the x, sine of x, and cosine of x. So let's start with e to the x. So, and step one is, remember, f of x is e to the x. So f prime of x is also e to the x. F double prime of x is e to the x. So I'm finding a general formula for the derivative. And f, nth derivative of f, is also e to the x. Now step two, remember to evaluate what's the point A, the function at A. Step three, evaluate all the derivatives at A. Oh, it turns out f prime of A is e to the A, f double prime of A is e to the A, and so on. Now let's try to write out the nth Taylor poly. So we start with t n of x. Start with the value of the function. Let me write this down. So it's f of a plus the first derivative times x minus a plus the second derivative times x plus the second derivative evaluated at a times x minus a to power 2 divided by 2. Then the third derivative at a, x minus a to power 3 over 3 factorial, and so on. Let's put 3 dots, meaning that for all values, you can do this. So that's a general formula for the nth derivative, for nth. So this is a general formula for the nth Taylor polynomial. Now I'm going to find Tn of x for our function. We evaluated this f of a, and it was e to the a. F prime was e to the a. F double prime was e to the a. And all the way, Fn evaluated at a is that. So it seems like it's e to the a and is in common between all the terms, and so you can factor it out. I want to mention if a is equal to 0, e to the a is going to be 1, and there is a famous, that this one is more famous than e to the a, which is the Taylor poly of e to the x at centered at 0. And so this is the shape of that. Now, can we do this for sine and cosine of x? So, Taylor polynomials for sine of x. The first thing that we want to do is step 1, try to find a routine for the derivatives. So let's see, what is f prime of x if f of x is sine of x? That would be cosine of x. Then f double prime of x is negative sine of x. Then f triple prime of x. Then f triple prime of x is negative cosine of x. And f to the fourth of x, the fourth derivative, is sine of x. So after 4 derivatives, we went back to where we started. In here, in step 2, let's evaluate the sine at, let's say this is centered at x equal to 0. So f of 0 is going to be 0. Now, step 3, let's evaluate. Again, one more try. When we arrived at the fourth derivative, we realized that we're going to do a cycle. So we're going to go back to here, basically. After every fourth derivative is going to be the same as the original. So basically, the fifth derivative is cosine, the sixth derivative is negative sine, and so on and so forth. It repeats. So now, what does this mean? It means that f prime evaluated, so evaluate derivatives. So f prime at 0 is cosine of 0, which is 1. Then negative sine of 0 is 0. Then f triple prime at 0 is negative 1. Then it's again 0. Then we know it's going to be 1. Then it's going to be 0. Then it's going to be negative 1. So for every, and this was the first derivative. So when I'm writing down the Taylor polynomial, I don't know what order. Let's put in 4 for now. And I want to come back to the so when I'm trying to compute the Taylor polynomial, let's try to compute the Taylor polynomial of degree 3 of x. The first term is just going to be 0. Then I will have a 1 times x minus 0. And then I will have another 0. So this term is 0. Then I will have a negative 1 sign. So it would be negative 1 times x minus 0 to power 3 over 3 factorial. Now basically clean it up. It seems like I'm skipping every other value, and the sign is is switching from positive to negative, and so on and so forth. Now, if I want to write the degree 5 polynomial, I know all the way to degree 3, I had this. I know the degree 4, so this was 1, 2, 3, 4 is going to be 0. Even degrees are going to be 0. Even degree terms are going to be 0. And then on the 5th one, I will have a positive x to the power 5 over 5 factorial. And then degree 7, for example, I know I'm going to switch the sign and skip 1. So I write the degree 5, and then I know degree 4 term is 0, and then the degree 7 is negative 1. Similarly, with the same process for the Taylor polynomial for cosine, Taylor polynomial for cosine of x centered at 0. Let's say that in that case, basically, Taylor polynomial of degree n, when n is even this time, is going to look like this, basically. The first term is 1, then the second, so the first term, or the value of the function, is 1. Then the next term is going to be x to the power 2, and it's going to be a negative value. And then we will have the next term would be x to the power 4 over 4 factorial. Then sign changes, x to the power 6 over 6 factorial, and so on. And then the last term, depending on how many plus and minuses you went, and basically indicates, and if n is even, then you can have either plus or minus x to the n over n factorial.